Okay, in this video, we're going to look at section 3.1, the law of sines. Up until then, we've been able to solve triangles using theories about right triangles. But can we solve triangles when they are not right? And we're going to look at all the different angle relationships that we had from triangles. And today, in this video, we're going to focus mostly, or mainly, and only on bullet points 1 and 3. So we're going to have two angles on any side, and then we're going to look at side, side, side. Now, first, let's review some of the basic ideas of a triangle. Then we have an angle. They're all represented with capital letters, and their sides are always directly opposite of the angle. So A goes with little a, angle B goes with little b, and angle C goes with little c. And what is the law of sines? Well, here's the law of sines. It says that A over the sine of A would be equivalent to B over the sine of B, which is also equivalent to C over the sine of C. Or another way that we could say this is that as long as our ratios are proportionate, we could flip these fractions completely upside down, and we can have sine of A over A, which is equivalent to sine of B over B, which again is equal to sine of C over C. Now, you do not have to solve a triple equality. We're just saying that either the sines of A is equal to B, or the sine is equal to A. The sine of A is equal to sine of C, or B could be equal to C. One of those three relationships could be possible. So let's look at an example of how we can use the law of sines to solve a triangle. Well, first off, we have the angle side, and it wants us to find all the remaining angles in the sides. Well, since we are given two of the three angles, let's use what we know about triangles in general. We know that there's 180 degrees in a triangle, so why don't we go ahead and start off with the easiest thing. Let's figure out what angle A is. Let's take 180, take away 29, let's take away 102, and that'll give us angle A. We know for a fact has to be 49 degrees. So we got all the angles taken care of, but we need to go in and figure out what side A is, and we also need to figure out what side C is going to be equal to. There is only one relationship that we do know for a fact of in this triangle. We have angle B, which is 29 degrees, and the side opposite, side B, is 28 degrees. So we're going to use that ratio to figure out what side A is and what side C is. And just a tip to help make law of sines a lot faster to you, you're going to always want to put your variable, the thing that you're trying to find, in the upper left-hand corner of your fraction to minimize the amount of cross multiplications that you'll have to do. So we're going to start with side length A. We're going to go in alphabetical order here. So what I need to know, I'm going to put the top left, there's my variable A. The angle that corresponds to it would be 49 degrees. We just found that. So sine of 49. So the side length of B, the one that we do know, goes in the top right. We're going to divide that by the sine of 29 degrees, and we would then try to cross multiply, or really all we need to do is just multiply both sides by the sine of 49. It says A then would be equal to whatever 28 times the sine of 49 is, that number we're going to divide by 29. We type it into our calculator. Again, make sure it's in degree mode and not radian mode. And we get an approximate number that A would be 43.6. Again, we're rounding there to the nearest 10. About 43.6 feet. So we've got A taken care of. The last measurement we need to find would be side length C. So again, we're going to use that ratio, 28 over the sine of 29, to figure out what side length C is. We don't know what C is, so that's what I'm going to put up in my top left-hand corner of my ratio. And just like we did in the first ratio, we multiplied by the sine of 49. Here, we're going to multiply both sides by that orange sine of 102. So we have this statement. C would be equal to 28 times the sine of 102, all divided by sine of 29. Once again, we're going to type it into the calculator, and we see that sine is about 56.5 feet. So we've taken care of what it asks. We found all the remaining angles, which happen to be A, and the remaining sides were A and C, and we've solved everything in this triangle. So that would be the angle relationships, or the triangle relationships of angle, side. We're going to jump down to an application problem where we have angle, side, angle. We have a triangle embedded in here. We have a pole, a telephone pole or utility pole that's in the ground, but it's not quite perpendicular to the ground. We see that it's kind of off-centered there. So we then, what's that measure of that angle? Well, we have 90 degrees from side length C to the vertical line, but then we're going an extra 8 degrees. So I would have to do 90 plus 8 to give us 98 degrees. So then what I'm going to do is I'm going to extract mainly the picture of this triangle here off to the side. See, now I've changed angle B to 98 degrees. We still have 43 for angle A, and side length C is 22 feet. This problem only asks me how tall is the pole, so we only got to figure out what side length A is in this problem. We do not have to figure out all the other side lengths or any of the other angles unless we needed to solve this problem. And as it turns out, we do need to find angle C to be able to use the law of sines here, because I have the side opposite of angle C, but I don't have its missing angle. Luckily, I have 2 of the 3 angles, so again, we can use 180 minus those 2 angles to figure out what angle C is. It gives us 39 degrees. So we're going to use 39 degrees in our law of sines to be able to figure out what side length A is, or in other words, how tall the pole is. So we go through what I need to know. My variable is going to be in the upper left-hand corner of my ratio. The angle that goes with side length A is 43 degrees, so I'm going to put sine of 43 on the bottom. And this would be equal to the side length of C, 22, over the angle that goes with it, which would be sine of 39. I'm going to cross multiply over with that sine of 43 degrees. So what I type into my calculator will just say 22 times the sine of 43. We're going to take that number and we're going to divide it by the sine of 39, do a little bit of rounding, and it comes out that the pole is about 23.8 feet. So just our last statement that we're going to make, and put it in words. The pole is approximately 23.8 feet tall. And there's using the law of sines to be able to solve some relationships with 2 angles on one of the given sides.